In 1493, on his second voyage to the Caribbean, Christopher Columbus and his crew stepped ashore on islands they had never seen, surrounded by plants they could not name. Among them was a strange, soft-fleshed fruit growing on a tree that barely looked like a tree at all, more like an oversized weed with a crown of leaves and no branches. The Taino and Carib peoples who lived there called it ababai. According to a story repeated for centuries, Columbus tasted it, and what he tasted convinced him he had found something almost holy. He is reported to have called it the fruit of the angels. Whether he used those exact words in that exact moment is not something any surviving ship's log can confirm with certainty, but the phrase attached itself to this fruit and never let go. Here is the scale of what was happening around that fruit. Roughly 200 years later, on ships crossing the Atlantic and the Pacific, sailors were dying by the thousands from scurvy, dysentery, and diseases nobody on board could properly name, let alone treat. Naval historians estimate that scurvy alone killed more than 1 million sailors across the roughly 3 centuries of the age of sail. 1 million sailors. Entire crews were reduced to a fraction of their original number before they ever reached land. Voyages that were supposed to take months stretched into a year or longer, and every additional week at sea was another week without fresh food, another week for the body to slowly break down from the inside, gums bleeding, old wounds reopening, teeth loosening in the jaw. And into this world of rot, salted meat, and desperate improvisation came a soft, orange fruit that sailors on tropical layovers discovered could ease their stomachs, help them digest the unforgiving rations that made up their diet, and, they believed, keep them alive a little longer. This was not a rare, ceremonial substance reserved for kings. This is a fruit you can buy today for around $1 at almost any grocery store in the world, tossed into a smoothie, sliced onto a breakfast plate, barely given a second thought. So how did a soft, unassuming fruit from a Central American jungle end up nicknamed by one of history's most famous explorers, carried across 2 oceans by desperate sailors, and eventually distributed to nearly every tropical nation on Earth? How did it go from a wild jungle plant nobody had bothered to name in any European language to a genetically engineered crop at the center of one of agriculture's most consequential scientific rescues? That was the 1490s. But Papaya's story does not start with Columbus. It starts almost 10,000 years earlier, in the lowland forests of southern Mexico and Central America, in a landscape of dense jungle canopy, volcanic soil, and rivers that flooded and receded with the seasons. The wild ancestor of the papaya tree grew scattered through those forests long before any human hand touched it, a lanky, single-stemmed plant crowned with a burst of deeply lobed leaves, producing small, bitter, seed-filled fruit that bore only a passing resemblance to the smooth, sweet papayas found in supermarkets now. Botanists classify it as Carica papaya, and here is a detail that surprises most people. Despite growing 20 feet tall and looking every bit like a tree, the papaya plant is not a tree at all in the traditional sense. It is technically the largest herbaceous plant in the world, a giant herb with no true wood, its trunk built from tightly packed leaf bases rather than bark and rings. No growth rings, no true timber. Cut it down and you will find something closer to a stalk of celery scaled up to 20 feet than anything resembling an oak. Ancient peoples living among these plants noticed something else entirely. Cut the unripe fruit, the stem, or the leaves, and a milky, sticky sap oozed out. That sap, they discovered through trial and repetition across generations, could soften tough meat, ease an upset stomach, and, applied directly, help calm a wound. Wrap a tough cut of meat in papaya leaves overnight, and by morning it cooked up noticeably more tender. Rub the unripe fruit sap onto skin, and swelling and irritation seemed to fade faster than they otherwise would. None of this came from a laboratory. It came from thousands of small, repeated experiments, most of them unrecorded, conducted by people whose names history never bothered to preserve. They did not know the word enzyme. They did not know the word protease. They were using both anyway. Archaeobotanists studying plant remains and early agricultural sites across Mesoamerica believe that indigenous peoples in the region spanning modern-day southern Mexico, Belize, Honduras, and Costa Rica began actively managing and selecting papaya plants sometime between 4,000 and 7,000 years ago, favoring individuals with sweeter, larger, less bitter fruit. This was not formal science. There was no laboratory, no controlled experiment, no written record of which seeds were saved and which were discarded. It was patience, observation, and generations of quiet, cumulative decision-making, the same slow process that gave the world corn, beans, and squash. Pick the best fruit, save its seeds, plant them near the village. Repeat for a few hundred years. That is domestication, and it worked on papaya just as it worked on nearly everything else humans learned to eat. Now, there is a persistent legend that circulates in parts of Central America claiming that a specific healer or shaman first discovered the medicinal power of papaya sap after using it to treat a snakebite, and that this single act of desperation is why the plant became sacred in certain communities. Historians and ethnobotanists generally treat this as folklore rather than documented history, since no written record from the period survives to confirm it. But the fact that a story like that exists at all, passed down independently in multiple communities across the region, tells you something about how deeply this plant was woven into daily survival long before any European ever laid eyes on it. By the time large Mesoamerican civilizations were building temples and calendars, papaya had already become a familiar presence in dooryard gardens, tucked in among the more heavily cultivated staples of maize and beans. It did not carry the imperial weight of cacao, which fueled Aztec ritual and functioned as a form of currency, or the sacred centrality of maize, which the Maya believed humans were literally created from according to their own origin stories. Papaya occupied a humbler, more practical role. It was food. It was medicine. It grew fast, produced fruit within a year of planting, and required little effort to maintain, which made it a reliable, low-stakes crop for individual households rather than a resource that ambitious rulers fought wars over. Here is the detail that makes papaya different from crops like sugar or tobacco that so often dominate this kind of history. It never became a monopoly product for any single Mesoamerican civilization. No dynasty rose or fell on papaya harvests. No war was fought over papaya groves. It thrived instead in a kind of quiet, distributed usefulness, present in nearly every warm climate community from southern Mexico down through Central America, valued not for the wealth it generated, but for the relief it provided. Unripe papaya, rubbed onto meat or wrapped around it during cooking, tenderized tough cuts from animals that had not been selectively bred for tenderness the way modern livestock has. Ripe papaya, eaten fresh, settled unhappy stomachs. The leaves, boiled into a bitter tea, were used to treat fevers and digestive complaints that had no other name. This was survival-level medicine in a world without pharmacies, without refrigeration, without any of the safety nets people alive today take for granted. In a world like that, a fast-growing plant that both fed you and treated you was not a luxury. It was insurance against a season going badly. Here is a small etymology aside worth pausing on, because it explains why the fruit is called what it is called in half the languages on Earth. The word papaya itself almost certainly comes from that Carib and Taino word, ababai, filtered through Spanish pronunciation and spelling as colonists adopted it. That single indigenous word then rode along on the same ships that carried the seeds, which is why, centuries later, a market vendor in Manila, a farmer in Lagos, and a grocery clerk in Mexico City can all use recognizably similar words for the same fruit. A linguistic fingerprint left behind by a language and a people that European colonization otherwise did an enormous amount to erase. In parts of Australia and the Caribbean, papaya took on a different name entirely, Pawpaw, a word borrowed from an entirely unrelated North American fruit that happened to look vaguely similar, creating a naming confusion that persists in supermarkets and cookbooks to this day. Ask for a pawpaw in Melbourne and you will get a papaya. Ask for one in rural Ohio and you will get a completely different fruit from a completely different plant family. Then came 1492, and the story of papaya, like the story of so many American crops, was violently rerouted by contact with an entirely different hemisphere. When Spanish and later Portuguese ships began arriving in the Caribbean and along the coasts of Central America, they encountered dozens of unfamiliar plants, and their reactions ranged from fascination to outright suspicion. Papaya was, relatively speaking, one of the easier fruits for Europeans to accept. It did not carry the psychoactive reputation of tobacco, which some clergy in Europe genuinely debated as a possible tool of the devil because of the way it altered the mind and clouded judgment. And no, that is not something anyone made up. That was a real theological argument made by real clergymen, weighing whether a New World plant that changed a person's state of consciousness could possibly be a gift from God or something closer to a temptation from the other direction. Papaya faced nothing like that scrutiny. It did not carry the strange, almost alien appearance of the pineapple, which took decades to be widely believed edible rather than purely ornamental, displayed in European greenhouses more as a curiosity than a foodstuff. Papaya looked, more or less, like a melon, tasted sweet, and did not require Europeans to rethink their entire framework for what food could be. Spanish colonists and sailors adopted it quickly for exactly the reason the legend about Columbus suggests, because it tasted good, and, more importantly, because it seemed to help with the very real, very common problem of digestive distress on long voyages and in unfamiliar climates. Here is where the story genuinely shifts from local curiosity to global commodity. By the early 1500s, Spanish ships were carrying papaya seeds from Hispaniola and the wider Caribbean out along their expanding trade networks. This was not a random accident of drifting seeds on ocean currents. It was deliberate. Ships needed provisions for punishing multi-month voyages, and any fast-growing, edible plant that survived transplantation was worth carrying in a barrel of soil below deck. Papaya, with its rapid growth cycle and tolerance for a wide range of tropical soils, fit that need almost perfectly. Plant a seed in a new port, and within 8 to 18 months, depending on climate, a returning ship's crew could find a tree already fruiting. Spanish and Portuguese vessels carried papaya seeds across the Pacific to the Philippines by the mid to late 1500s, using the same Manila galleon trade routes that carried silver, silk, and sweet potatoes between the Americas and Asia. From the Philippines, papaya spread rapidly through Southeast Asia, reaching India, Malaysia, and southern China within decades. Portuguese ships, meanwhile, carried it along the African coast and into India through their own separate trading posts, planting it in colonial gardens from Goa to Mozambique. By the middle of the 1600s, papaya was growing in tropical regions on nearly every populated continent, a spread that took less than a century and a half from its first contact with European sailors. Think about that for a second. A plant native to a relatively narrow strip of Central American jungle had within roughly 150 years become a familiar tree in gardens from the Philippines to West Africa to southern India. Almost no deliberate marketing campaign, no royal decree, no organized agricultural ministry made this happen. It happened because sailors kept seeds in their pockets, because the plant grew fast enough to bear fruit before a ship's crew rotated out, and because, once established, it needed almost nothing from anyone to keep producing. Compare that to a crop like the potato, which took roughly 2 more centuries after its arrival in Europe to be widely trusted as food fit for human consumption. Papaya faced almost none of that resistance. It simply spread, quietly, port by port, garden by garden. This is where the story takes a turn nobody usually expects, and it circles back to the sailors themselves. Long ocean voyages in the 15, 16, and 1700s were defined by scurvy, a disease caused by vitamin C deficiency that killed more sailors during the Age of Sail than combat, storms, and shipwreck combined. Papaya, rich in vitamin C, along with citrus fruits that would later become far more famous for solving this exact problem, offered ships stopping in tropical ports a genuine, if inconsistently understood, lifeline. Sailors did not know the biochemistry behind any of it. They only knew that fresh fruit, papaya included, seemed to make the sickness go away, and that unripe papaya rubbed into salted, tough shipboard meat somehow made it easier to chew and easier to keep down during weeks at sea with nothing else on the menu. In a world without refrigeration, without any scientific understanding of nutrition, and without any reliable way to preserve food across months at sea, this was not a minor convenience. It was, in a very literal sense, the difference between a crew making it home and a crew not making it home. Ship surgeons in the 16 and 1700s working almost entirely by trial and observation rather than any formal theory of vitamins, which would not be identified for another 200 years, recorded again and again that crews who took on fresh tropical fruit during port stops fared better on the remaining leg of a voyage than crews who did not. They had no idea why. They just knew it worked, and papaya, wherever it grew, became one more entry on the very short list of things worth loading onto a ship before it set sail again. If you are finding this interesting, hit subscribe. We cover stories like this every week, and you will not want to miss what comes next. Because the story of papaya does not stop at the deck of a Spanish galleon. It gets stranger, more scientific, and considerably more industrial from here. Before it does, though, it is worth pausing on a chapter of papaya's history that gets far less attention than the sailors and the shamans, and it is not a comfortable one. As European powers built out their colonial plantation economies across the Caribbean, Central America, and later South and Southeast Asia, papaya rarely stood at the center of those brutal systems the way sugar, coffee, or cotton did. There was no papaya-driven slave trade on the scale of the Caribbean sugar industry, no equivalent of the sugar plantations where the average life expectancy of an enslaved worker was often just a handful of years after arrival. But that does not mean papaya's colonial history is a clean one. Papaya trees were frequently planted alongside the true cash crops on plantations worked by enslaved and, later, indentured laborers across the Caribbean and parts of South Asia, grown in kitchen gardens and field margins as a food source to keep a forced workforce alive and productive enough to keep harvesting the crops that actually generated profit for colonial landowners. In this sense, papaya occupied an uncomfortable dual role. It was a source of nutrition and relief for people trapped inside some of the most exploitative labor systems in human history, and at the same time, its very usefulness helped sustain those systems by keeping enslaved and indentured workers healthy enough to keep working. This was not sugar's story, driving the transatlantic slave trade directly, but it was not an innocent bystander either. It was there, quietly, on the margins of plantations built on forced labor, doing exactly what it had always done, feeding and healing people, whether or not those people were free. That uncomfortable history did not end with the abolition of slavery. In the 19th and 20th centuries, as papaya became a genuine commercial export crop in regions including Central America, the Caribbean, and South and Southeast Asia, its production increasingly relied on low-wage migrant and seasonal agricultural labor, workers who cleared fields, pruned trees, and harvested fruit for wages that plantation owners and export companies kept deliberately low in order to compete in a global fruit market that prized cheap, year-round supply above all else. Labor advocates in several major papaya-producing regions have documented conditions on some commercial farms that include long hours in extreme heat, inadequate protective equipment around pesticide application, and, in certain documented cases, exposure to chemicals used to control the very pests and viruses that threaten commercial papaya orchards. This is the part of the story that does not make it onto the smoothie menu or the health blog. The cheap, dollar-a-fruit papaya sitting in a supermarket display case in a wealthy country is, in many cases, the product of a global agricultural supply chain that keeps prices low partly by keeping the wages of the people who grow and pick it low as well. This decision, to prioritize scale and low cost over almost everything else, seemed like a purely economic one at the time. It was not. It shaped who profited from papaya's global rise and who did not, and that imbalance persists in parts of the industry to this day. The clock was already ticking on a very different kind of transformation, though, one that would move papaya out of the folk remedy category entirely and into a modern laboratory. For roughly 300 years after that initial spread, papaya remained a folk remedy and a subsistence crop, useful, beloved in its growing regions, but scientifically unexamined in any rigorous sense. Nobody had isolated what, exactly, made the sap work. That changed in the 1870s, when European chemists studying the milky latex of unripe papaya began identifying and describing the proteolytic activity inside it, meaning its ability to break down proteins on contact. Historical accounts differ somewhat on the precise year and the specific researcher credited with first coining the term, but the substance that emerged from this period of chemical investigation was named Papain, after the plant's own Latin name, Carica papaya. Here is the detail that makes this discovery satisfying rather than merely technical. What 19th century chemists in European laboratories were formally isolating and naming was something Mesoamerican peoples had been using functionally, without any of that vocabulary, for thousands of years. The lab did not invent the knowledge. It caught up to it, decades and decades late, and gave it a name that fit neatly into a scientific journal. It would take several more decades, well into the 1920s, 30s, and eventually the 1950s, for papain to be fully purified, standardized, and understood at a molecular level, eventually classified as a cysteine protease, an enzyme that relies on a specific chemical structure, a reactive sulfur-containing amino acid in its active site, to cut through the bonds holding proteins together. But here is the twist that turned papain from a scientific curiosity into a full-blown industrial product. Once chemists understood how to extract and stabilize it, papain became astonishingly useful far beyond the kitchen. It could tenderize meat on a commercial scale, which is why, to this day, if you buy a powdered meat tenderizer off a grocery store shelf in nearly any country, there is a strong chance papain is the active ingredient. Commercial enzyme companies founded in the mid-20th century, some of them still operating today, built entire product lines around papain, marketing it not just for meat, but for chill-proofing and clarifying beer during the brewing process, a use that traces directly back to the 1950s. It found its way into medical wound care, used by clinicians to help remove dead tissue from wounds and burns in a process called debridement, essentially letting the enzyme do a small piece of a surgeon's job without a scalpel. It found its way into chewing gum, into digestive health supplements sold in wellness stores, into cosmetics as a gentle chemical exfoliant marketed to soften and brighten skin, and into the leather and textile industries, where its protein-dissolving properties helped soften hides and treat wool fibers before dyeing. This was not about seasoning food. Papain became a quiet, invisible ingredient inside an enormous range of 20th century industries, present in products that, on the surface, had nothing whatsoever to do with fruit. By the middle of the 20th century, papain extraction had become an industry unto itself, entirely separate from the fresh fruit trade, and it followed its own distinct economic logic. Farmers in countries including Sri Lanka, Tanzania, Uganda, and later parts of Southeast Asia began growing papaya specifically for latex tapping, rather than for the fruit itself, slashing unripe green papayas on the tree in shallow, careful cuts, much the same way rubber trees are tapped, and collecting the sticky white sap that dripped out into small containers strapped beneath each fruit. That raw latex was then dried into a crude, brittle sheet, packed, and shipped in bulk to processing plants in Europe, Japan, and the United States, where it was refined, purified, and standardized into the pharmaceutical and food-grade papain sold to manufacturers around the world. This became, for a period, a genuine cash economy for smallholder farmers in several tropical nations. Entire family incomes built not around selling papaya fruit at the local market, but around the tedious, repetitive work of slashing hundreds of unripe fruits a day and collecting their sap before it dried in the tropical heat. Modern chemistry and biotechnology firms have added yet another layer on top of this older, sap-tapping industry. Recombinant and enzyme engineering companies now produce standardized, highly purified papain at industrial scale, sold in precisely measured units of enzymatic activity to pharmaceutical manufacturers, brewers, and food processors who need consistent, predictable results batch after batch. Something raw tropical latex, dependent on weather, soil, and the individual fruit it came from, could never reliably guarantee on its own. Meanwhile, the papaya plant itself was becoming a serious commercial crop in its own right, and nowhere tells that story more vividly, or more dramatically, than Hawaii. Papaya arrived in Hawaii sometime in the early 1800s, likely carried by traders and missionaries following routes similar to those that had already spread it across the Pacific. By the early 20th century, Hawaiian growers, aided by the island's volcanic soil and consistent tropical climate, had turned papaya into a significant local export, and by the mid-20th century, it had become one of the state's most recognizable agricultural products, second only to pineapple among the island's fruit crops, prized in markets as far away as mainland Japan, where a Hawaiian papaya could be presented as a genuinely special occasion gift. Then, in the 1940s, papaya ring spot virus arrived, an incurable disease spread by aphids that stunts growth, deforms fruit with ugly ring-shaped lesions across the skin, and eventually kills the tree outright. For decades, it remained a manageable regional problem, but by the early 1990s, it had exploded through Puna, the district on Hawaii's Big Island responsible for roughly 95% of the state's entire papaya production. Between 1993 and 2006, Hawaiian papaya production fell by more than 50%. 50%. Not a bad season, not a temporary dip, half of an entire industry wiped out inside little more than a decade. Farmers who had tended the same orchards for generations described walking their fields, marking infected trees with orange paint, and then cutting them down one by one, watching a livelihood disappear tree by tree in real time. This is the part that should genuinely impress you rather than frustrate you. A plant pathologist named Dennis Gonsalves, who had grown up on a sugar plantation on the very island the virus was devastating, spent years working with colleagues at Cornell University and the University of Hawaii on an unconventional idea. If the virus could not be stopped with pesticides, and it could not since no chemical treatment existed for papaya ring spot virus, perhaps the plant itself could be engineered to resist it, essentially vaccinating the papaya from the inside by inserting a small piece of the virus's own genetic material into the plant's DNA, training it to recognize and repel the pathogen before it could ever take hold. This was not a battle fought with pesticide sprayers, it was a battle fought with a gene gun. After years of research beginning in earnest around 1985, field trials starting in 1992, the exact same year the virus outbreak reached its most catastrophic point in Puna, and formal regulatory approval that took several more years to clear, two new resistant varieties, named Sunup and Rainbow, were released free of charge to Hawaiian farmers in May of 1998. Free. Not licensed for a fee, not sold through a corporate distributor, simply handed over to the farming community that desperately needed it. Within a matter of years, these genetically engineered varieties came to represent somewhere between 80 and 90% of Hawaii's entire papaya crop, and an industry that had been on the edge of total collapse was saved. Whether every detail of exactly how credit should be distributed among the various scientists and institutions involved remains a matter of some debate among those close to the project, since it was genuinely a collaborative effort spanning multiple universities and a private company, but the outcome itself is not in question. Papaya became the world's first genetically modified fruit to be commercially sold, years before genetically modified corn or soybeans became household terms in most consumers' minds. And it did so not to increase profit margins for a distant multinational corporation, but to save a regional industry, and the families who depended on it, from an unstoppable virus. And here is the uncomfortable postscript that the tidy, heroic version of this story sometimes leaves out. The very technology that rescued Hawaiian papaya farmers also triggered years of intense local political conflict, protests, and eventually a county-level ban on new biotech crops on the Big Island, passed in 2014, one that specifically had to carve out an exemption for the rainbow papaya that had already saved so many farms, since banning it outright would have destroyed the very industry the science had rescued. Gonsalves himself, once celebrated, described being booed at public meetings and followed by activists with cameras who called him, to his face, the bad man who invented GMOs. The science worked, unambiguously and measurably. The public reaction to that science, in Hawaii and far beyond it, was, and in many places remains, far more complicated, tangled up in broader anxieties about genetic engineering that had very little to do with papaya itself. Today, papaya is grown commercially in roughly 60 countries around the world, and the modern production numbers are almost dizzying compared to papaya's humble origins as a dooryard garden plant tended by families in Mesoamerica. Global papaya production sits at somewhere around 14 million metric tons per year. 14 million tons from a fruit that 400 years ago existed almost nowhere outside a narrow strip of Central American jungle. India alone accounts for well over a third of that total, producing more than 5 million metric tons annually, dwarfing every other producing nation, including Brazil, Mexico, Indonesia, Nigeria, and the Dominican Republic, which round out the rest of the world's top producers. Papaya is now, by volume, the third most widely produced tropical fruit on Earth, trailing only mango and pineapple, ahead of crops with far longer marketing budgets and far more recognizable brand names. The global trade in fresh papaya alone, separate from the processed pulp, dried fruit, and Papain that get shipped and sold under entirely different customs codes, moves hundreds of thousands of metric tons across international borders every single year, led by exporting nations such as Mexico, Brazil, Guatemala, and India, and flowing predominantly toward markets in the United States, the Middle East, and the European Union, where papaya remains, even now, marketed on grocery shelves as something faintly exotic, despite having spent the last 5 centuries becoming one of the most thoroughly globalized fruits in existence. Here is a relatable way to picture the scale of India's dominance alone. India's annual papaya harvest, more than 5 million metric tons, is roughly equivalent in weight to filling well over 300,000 fully loaded shipping containers, one after another, an amount that would stretch for hundreds of miles if lined up end to end along a highway. And that is just one country's output of a single fruit that 4 centuries ago existed nowhere on the entire Asian continent. But papaya is far more than just a piece of fruit sitting in a grocery aisle, and this next part tends to catch people off guard. Unripe green papaya, shredded raw, is the base ingredient of somtam, the fiery, tangy green papaya salad found across Thailand, Laos, and Cambodia. A dish so central to the region's cuisine that it has become one of Southeast Asia's most recognizable culinary exports, served everywhere from roadside carts to fine dining menus on the other side of the planet. Papaya leaf tea, meanwhile, has become a genuinely significant subject of modern medical research, particularly in parts of South and Southeast Asia, where traditional and complementary medicine practitioners have long used it as a treatment to help raise platelet counts in patients suffering from dengue fever, a mosquito-borne illness that sickens tens of millions of people every year in tropical regions. This traditional use has since drawn the attention of formal clinical researchers running small trials, though results so far remain preliminary, and papaya leaf tea is not, and should not be treated as, a substitute for proper medical treatment for a disease that can be genuinely dangerous. Papain, meanwhile, has quietly made its way into an almost absurd range of modern products that have nothing to do with the tropics at all. From contact lens cleaning solutions designed to dissolve stubborn protein deposits, to protein digestion supplements sold in wellness stores by the millions, to industrial stain removers, to, yes, that powdered meat tenderizer sitting in most American kitchen spice racks, likely without a single person in that household knowing where the active ingredient actually comes from. Some researchers have even explored papain's potential in more experimental medical applications, including studies into its use in certain wound and skin treatments, an area of ongoing scientific interest rather than settled, widely adopted practice. Papaya seeds, often discarded without a second thought, carry their own small legacy: edible, faintly peppery, sometimes dried and ground as a black pepper substitute in regions where the fruit grows abundantly and nothing about it goes to waste. It was there in the jungles of Mesoamerica, quietly domesticated by peoples whose individual names history did not bother to record. It was there on Spanish ships, carried across 2 oceans in the pockets of sailors who did not know they were founding a global agricultural network. It was there, choking on tropical illness, offering weary crews a small measure of relief against a disease that killed more men than warfare ever did. It was there, on the margins of plantations built on forced and underpaid labor, feeding and healing people trapped inside systems that gave them almost nothing else. It was there, in 19th-century European laboratories, being reduced from folk remedy to isolated enzyme with a Latin name. It was there, in a Hawaiian orchard on the edge of collapse, saved by one of the earliest and most consequential applications of genetic engineering in modern agriculture. And it is there, right now, sitting quietly in your refrigerator or your local market, costing you about $1, asking nothing of you but a knife and 5 minutes. Not bad for a fruit most people cannot even confidently explain the origin of. If any part of this surprised you, and I am guessing at least one part did, let me know which one in the comments. Hit subscribe if you have not already, and I will see you in the next one.